Welcome to our review on asteroids, comets and the moon. First thing we're going to look at then are asteroids. Now whenever we're talking about an asteroid, what we're referring to is a piece of rock that's orbiting the sun. Now the largest of these we think has diameters of about 500 kilometers, but the vast majority of them are smaller than this. They don't actually have a regular shape. They've got quite unusual shapes, as the picture at the bottom shows you, because the gravity is not strong enough to have pulled them into spheres. Now, what we actually believe is that these asteroids are actually leftovers from when the solar system was formed, and we find most of them in this thing called the asteroid belt, which is located between Mars and Jupiter. Second object we can look at then are comets. Now, comets are made of ice and dust, and what we find is that there are hundreds of comets orbiting the sun, but they travel in a different orbit to things like our planets. They travel in an elliptical orbit, so it's kind of more egg-shaped, if you like. Now, what we actually see happening is, as that comet comes closer to the sun, it's going to move faster. And the reason behind that is that as it gets closer to the sun, the gravitational attraction is stronger. So that means it's going to pull it round quicker and therefore increases its speed. When that comet does also get near the sun, what we see is this very distinctive tail forming from the comet. And that's all down to those solar winds melting those bits of ice there, and then we get that very distinctive tail you can see in the picture, which is how we see our comets in the sky from Earth. Every so often, we do actually have either an asteroid or a comet hitting the Earth. So this has happened in the past, and it will happen in the future. And what we actually find is that when one of these objects actually does impact on the surface, then we get huge amounts of hot rock and dust thrown up into the atmosphere. Now this isn't some kind of pathetic little impact that doesn't really do much in terms of destruction. We're talking about very explosive impacts, and then they can also generate these enormous fires that are hard to comprehend in their magnitude. And we also will have even more dust from these fires and these explosions as a result of their impact that could actually lead to the sun being blocked out. If we don't have the sun, then we're going to see rapid climate change and also the potential resulting extinction of some species. So obviously if we think back to the dinosaurs, we did have a big impact 65 million years ago when the dinosaurs went extinct, and some people believe that it was that actual asteroid that impacted the Earth 65 million years ago that led to the extinction of the dinosaurs. These days we do try to actually work out whether we're about to be wiped out by something coming from outer space or not. And what we actually do is we try to identify these things called NearEarth Objects, or NEOs. So these are literally any comets or asteroids that are on a possible collision course with the Earth. Now what we will do is we'll be using very powerful telescopes to actually detect them, and the reason we can see them is because they reflect light from the sun. The big downside though is that making these observations is quite difficult, because the things we're looking for are relatively small and they're very fast moving. So what we actually find is, while we are looking for them, there's no guarantee that we're necessarily going to see them all. Once we've actually observed one of these NEOs, then what we can do is take several measurements and then use some very complicated maths that we don't need to concern ourselves with to actually calculate their trajectory or their path. So that then tells us how likely it is that they're going to actually impact the Earth, or whether they're just going to be a close call. The last thing we're going to think about then is our moon. Now, the moon is the Earth's only natural satellite. So a satellite is anything that orbits the Earth, and a natural satellite is one that obviously we haven't put there. So the moon is the only natural satellite of Earth. Now, what we need to understand then is how the moon actually came to be there. So what formed the moon? And the one theory that we need to remember is the one where basically we had a planet the size of Mars colliding with Earth when the solar system was still very young. So we've basically got two planets coming together and colliding. As a result of that collision, what we found was those heavier elements like our iron sank down to the middle, and that's what makes up the core of the Earth, which is mainly iron if you remember. And then those lighter elements were thrown out into orbit. And then over time, gravity pulled those lighter elements together, and that then formed the moon.